Boom. Hello and welcome back to Calculus 1, section 3.5, derivatives of trigonometric functions. Yes, trigonometric functions are functions. They have the graphs, they have the tangent lines, therefore they must have derivatives that give us those tangent lines. Now, the proofs for these assume knowledge of certain limits, and they're done in a textbook. There are even better proofs done in Calculus 2. We again are not in honors option, so I'm not going through these proofs. They're cool exercise for those of you who want to, further your mathematical frontiers, and definitely see me during office hours. For trigonometric functions, you are going to have trigonometric function answers. So the answers stay in the realm of trig functions. We are going to memorize 6 derivatives, and then we'll combine them with product rule and quotient rule and do the tangent line problems to make it a little bit spicier. So we start by saying that the derivative of sine x is cosine x, and the derivative of cosine x is negative sine x, and the derivative of tangent x is secant squared x, and the derivative of cotangent x is negative cosecant squared x, and the derivative of secant x is secant x tangent x, and the derivative of cosecant x is negative cosecant x cotangent x. Or put this on a cloud. I need you immediately to notice trigonometric pairs. That has to be first thing you see. Sine with cosine, tangent with secant, cotangent with cosecant. Observe that these formulas never stray from that pairing. Sine, cosine, cosine, negative sine, tangent, secant squared, secant x, secant, tangent. The pairing is never broken in any of these formulas. Are we 100% on that one? Next one. Observe, looking from left to right, they all have same form, except all of the ones on the right are negative. So if it starts with a, it's negative, like the cosine, and right, and the cotangent, and right. So if it's a co, it is going to be negative. Are we 100% on that one? So cosine, negative sine, secant squared, negative cosecant squared, secant tangent, negative cosecant cotangent. So do we all kind of get the vibe that we memorize this one and the other one is the same, just different? Right? Now, you must know this because integration is coming at some point where we do these things backwards. The integral of cosine is going to be sine, and the integral of secant squared is going to be tangent, and so on. So right now, you are not learning just derivatives. You are actually learning the integration table as well. Because when I put the integral over here and dx, the integral of cosine x dx will be sine x plus c. So you're learning all of that stuff at once. Now, we do proofs for sine and cosine using the limit definition from 3.1. It's done in a book. if you are interested in that, obviously you will read it, and if you don't understand any concept that is there, please ask me. You have to use the because it's going to be sine of x plus h, so you have to use the sum formula for sines and cosines, and then when you break it apart, you will do some splitting the fractions and so on. It's really interesting proof. It's a cool exercise, but again, it's not an honors option of the class, so we don't cover that in this class. But if you are interested, please see me, and I will go through details if you don't understand what happened. The other ones you are responsible for. The proofs of the bottom four. So you're not responsible for the proofs of the first two, but you are responsible for the proofs of the bottom four because those are basic exercises of quotient rule. And I'm going to ask you now to prove that derivative of cotangent x is negative cosecant squared x. I'm asking you to prove that because it is a basic quotient rule. Where do you start? Very good. So you will convert the cotangent into cosine x divided by sine x, and you will unleash the quotient rule upon this thing. Go on, while we're still young. You have the formula for quotient rule. You want me to write it over here so you don't have to flip? Fine. That's invisible ink. There you go. Cosine is u, sine is v, and plug in here.
Does it matter in that if we do this instead, or does it? Or what is that? This one. Are these different? So it doesn't matter.
So it does, yeah, because the subtraction is not commutative. You can't flip the terms. You must go with the VU prime. For product rule, it doesn't matter because the product rule is better than the addition. So if you swap them. Yes, you can flip your product rule if you want to into VU prime plus UV prime because it doesn't matter. It's commutative, right? It's plus. But for the quotient rule, you must have VU prime minus. It's not commutative, all right? All right, let's see. Keep cranking this up. And all the books that used to be in math class have writing like this.
Mine's good except for getting my hands up. And this one is having a bit awesome.
Right, let's take a look at this problem together. So cosine x divided by sine x, it is the quotient rule. So we take sine x, right, and we square it. And then we have sine x. The derivative of cosine is negative sine, right? Minus. And then we have copy the cosine. And then derivative of cosine, derivative of sine is cosine. Great. We have negative sine squared x minus cosine squared x over sine squared x. What do we do now? What do we do? We can't cancel. We can't cancel this because of the minus cosine. But what can we do? Beautiful. Nice. What am I going to do now? Nice. Pythagorean identity. Yes, very good.
We need to know all the Trig identities, or just
For this class, not all. For this class, you need to know Pythagorean identities, and you need to know, if I say all 9, you will freak out. There are actually 3, and each one of those can be flipped. So, you know, there are 9 forms. But what you must know is that tangent x is sine x over you must know what I said on the first day. Cotangent x is cosine x over sine x. Secant x is 1 over cosine x. Cosecant x is 1 over sine x. Sine squared x plus cosine squared x is equal to 1. And then they branch into 2, right? Where the sine squared x is 1 minus cosine squared x, and the cosine squared x is 1 minus sine. You have to be able to recognize these formulas, whatever flavor you get them in, because, you know, of these kind of trig derivatives and later on. Now, if you take this equation and you divide it through by cosine squared, sine squared by cosine squared gives you tangent squared, and cosine divided by cosine gives you 1, and 1 divided by cosine gives you secant. And look at this. The pairing, tangent secant pairing, is not broken. Right? It's still good. 2 forms. 1 is equal to secant squared x minus tangent squared x, and tangent squared x is equal to secant squared x minus 1. If you take the original formula and divide it by sine squared x this time, you get 1 plus cotangent squared x, which is equal to cosecant squared x, which I guess it's 2 forms of 1 is equal to cosecant squared x minus cotangent squared x, and cotangent squared x is equal to something, cosecant squared x minus 1. Everything okay? So these are the formulas that you must know now to survive. We are going to add power reducing for integration later on. If you don't know power reducing, there will be no integral of sine squared. You have to know how to power reduce. But that's later. So we'll add another 3 identities in chapter 5. And all of those carry over to your Calc 2. Hey, we're going to have parametrization. We're going to have polar coordinates. We're going to have trigonometric integrals, trigonometric substitution. All of that stuff carries through in Calc 2. So do yourself a favor and just, you know, learn little by little. And just hate those who gave you formulas before. It's okay. I said it right here. Because they did you disservice, right? Imagine if you have every single formula since day one where x to the m times x to the n is x to the m plus n, one of the first formulas. Imagine what kind of booklet would you have by now in Calc 3 with zero knowledge on anything? Flipping through 50 pages of formulas in Calc 3 trying to solve a problem on a test for 3 hours. Hey, I got it, right? The formulas that I needed were on pages 1, 7, 13, 25. You go through all of that stuff. So, yeah, you just gotta learn stuff. So there you go. This is your PreCalc 2. So go on. Have at it. Next one. What's the derivative of x cubed times sine x? What do I have to use here? No, the other one. Product. Nice. Copy first derivative of the second plus copy second derivative of the first, factor it, done. Sounds so easy, right? I will do one more problem and call it a day. Oh, exciting, right? Music to my ears. What does this mean?
Tangent line.
Tangent line, exactly. I love the way you sing it. Find the equation of the tangent line for the function 4 sine x cosine x at pi over 3. This is problem 62 in your textbook. There are 4 problems for tangent lines here. So do the other 3. Make sure you can do the tangent line for every section. You know what happens here, right? Take some derivative. We all have the same derivative. Now you could be fancy and, you know, factor out -4, and that would make it cosine squared minus sine squared. And if you know the identity, that is actually identity for cosine double x, and then you have less calculations to do. But again, we're going to leave that, you know, for those of you who are more trig friendly. In my case, I'm going to find m by plugging in pi over 3. So sine pi over 3 everything squared plus 4 cosine pi over 3 everything squared. So m is equal to -4. Sine of pi over 3 is, very good, squared, plus 4 times cosine of pi over 3 is, very good. When you square this, we get -4 times 3/4, right? Square kills the root, and then 2 squared is 4. Plus 4 times 1/4 is 1, right? Because 1/2 squared is 1/4. 1/4 times 4 is 1. So now 4 and 4 cancels, and the slope is -2. Woohoo! Right? So what do I have? What do I have? I have slope that it's -2. I have x that it's pi over 3. I need y. And y is the function computed at pi over 3. So that would be 4 times sine pi over 3 times cosine pi over 3, which is a calculation that we have to do. 4 sine of pi over 3 is square root of 3 over 2. And then cosine of pi over 3 is 1/2. These guys all cancel, and we just get root 3. Oh, what a wonderful soup of all of these. You have a number that it's a whole number, and then you have the, integer, and you have the pi of 3, and you have square root of 3. A, right? So y equals mx plus b. We are looking for b. Y is root 3. M is -2. This thing is pi over 3 plus b. So b is -2 pi over 3 minus root 3. Oh, nice. Tangent line. There it is. Slope is -2, so -2x, and b is the entire mess that we got. Yes?
In order to find the y, you always find the value that is from the initial. You always put the value in the initial constant, right? Not the derivative that you got.
You plug it in derivative as well.
With the pi over 3, you put it in the original function, right?
I did, but I also put it in derivative.
Put it in both. One gives you the slope, one gives you the y value.
That's it. Bravo. Yes. You plug pi over 3 into both original function and derivative. Derivative gives you the slope, original function gives you y. You have x, you have y, you have the slope, and you can find b. Cool? Of course cool. It's Calc 1. See you all next Saturday, or if you stop by office hours, see you sooner. Or Road Rockford Math Club or something.